Hello everybody. Today we're going to answer this arithmetic problem about clocks. Find the time between 2 and 3 o'clock when the hands of a watch are together. So it can seem like a tricky problem at first. We just have to think about it. And we should first recognize it's a catch-up rate problem. The hour hand moves slower than the minute hand. And, the time they're going to meet at can't be 2:10 because the hour hand will have moved, since then. So it has to be a little bit past 2:10. Now we can think of it this way. In 1 hour, the minute hand goes, so we have the minute hand. In 1 hour, it goes 60 minute spaces. And the hour hand in 1 hour goes, think about it, if it were 12 o'clock, it would go to the 1. If it were 1 o'clock, it would go to the 2. So it moves 5 minute spaces. Right? We want to get consistency to measure them. So we're measuring minute spaces. And so here's the key observation. We can say the minute hand gains 55 minute spaces every 60 minutes, right? 60 minute spaces is 60 minutes. In 1 hour, okay? So we can say in 60 minutes, I'm going to say. Okay, so we divide by 5, we get, it gains 11 minute spaces. It always goes 12 times as fast, and it's going to gain 11 minute spaces every 12 minutes, right? 5 times 12 is 60. We can simplify this to really get 1 over 12, okay? So it gains 11 minute spaces every 60 divided by 5 is 12 minutes, okay? And so I'm going to take this 11 minute spaces over 12 minutes, get to the really important point. Right, leave out the A to save some time. It gains 11 minute spaces every 12 minutes. So it'll gain 1 minute space every 12 over 11 minutes. Okay, so think about what we're talking about. The minute hand will gain 1 minute space every 12 over 11 minutes. How many spaces do we want it to gain? We want it to gain 10 spaces, right? So if 1 minute space takes 12 over 11 minutes, then 10 minute spaces is going to take 10 times 12 over 11 minutes. Okay, so we get 120 over 11. And I can just use my short division, or if you know your 11s pretty well, it's not a big deal at all. Okay, so I get a 0. So it's, like I said, it's going to be slightly past 2:10, past 2 minutes. So it's actually going to be at 2:10 and 10/11ths. Okay, so 10 and 10/11th minutes. Okay, after 2. So the key observation for these type of problems is that the minute hand gains 1 minute space every 12 over 11 minutes. It gains 1 minute space over the hour hand, okay? So that's very, very useful. It's going to gain a minute space every 12 over 11 minutes. So right now I wanted it to gain 10 minute spaces. So I said 10 times 12 over 11. Now, if it were 3 o'clock and the question was when will the hands meet? Well, I want them to gain 15. I want the gain to be 15 minute spaces. I want the minute hand to gain 15 minute spaces over the hour hand. So I would say 15 times 12 over 11. At 4 o'clock, I would say 20 times 12 over 11. So if you understand this very important concept, and I kind of went over the derivation, and there's plenty of other ways to do it. The quickest way is just to realize that the minute hand always moves 12 times as fast as the hour hand. So when the minute hand goes 12 minutes, the hour hand is just going to go 1 minute. So it's the minute hand is going to gain 11 minutes over the hour hand every 12 minutes. So then you can create a simple proportion, and then we get to the very important point that states that a minute hand gains 1 minute space every 12 over 11 minutes over the hour hand. Okay, good job.